Matrices from BCA first sem. In this class, we will study about the inverse of a matrix. We will see the properties of the inverse of the matrix and how to solve the 2 by 2 matrix and 3 by 3 matrix also. Okay, before that we will see the two definitions. It's very important to understand the inverse of a matrix, that is the singular and non-singular matrix. What is the meaning of singular matrix? What is the meaning of non-singular matrix? Okay. First, it is the singular matrix. What is the meaning of singular matrix? Means a square matrix A is said to be singular if and only if determinant of A equals to 0. If it is determinant of A equals to 0, then it is called as a singular matrix. And non-singular matrix means a square matrix A is said to be a non-singular matrix if and only if determinant of A is not equals to 0. That is called as the non-singular matrix. Okay, singular matrix means determinant should be equal to 0. So see here one example I will using the example I will explain here. It's a matrix 4 to 2 1. We need to find out the determinant of A here. So how to find out the 2 by 2 determinant here? First you need to multiply principal diagonal 4 into 4 and minus 2 into 2 is also 4. So what is here? The determinant came here 0. If it is determinant of any matrix is 0, that matrix you can call it as singular matrix. If it is determinant is not equal to 0, then it is called as a non-singular matrix. Very important, you need to remember this one. For 1 marks also they will ask the definitions, and they will ask they will give the questions. They will ask whether it is singular or non-singular. You need to find out the determinant of that particular matrix, and if it is 0, then you can call it as singular matrix. If it is not equals to 0, then you can call it as non-singular matrix. It's also for 1 marks also, it's a very important. Okay, now we'll see non-singular matrix example here. 5 into 1 is the 5, 3 2 is the 6, minus 6. Both are opposite sign, so you need to subtract here. It's a minus 1. Minus 1 is not equals to 0, so it is a non-singular matrix. Okay, definition is, it's very easy to remember. Just you write down this one. Determinant of A equals to 0, it's a singular matrix. Determinant of A is not equals to 0, it's a non-singular matrix. Okay, now we will come to our main topic, that is the inverse of a matrix. What is the inverse of a matrix? Okay, we will already saw the inverse law and inverse in the integers, multiplicative inverse and additive inverse. We already saw. What is the additive inverse? I will explain. See here, additive inverse. What is the additive inverse? Additive inverse means what? Additive inverse means if it is plus 2 is there, then this additive inverse is, we call it as a minus 2. Plus 2 additive inverse is minus 2. When you simplified this one, you will get the 0. 0 means what is this one? It is the additive identity. Additive identity. You will get the additive identity. Whenever you have if it is in addition means you are solved with the additive inverse, then you will get the answer should be additive identity. In the multiplicative also same. If it is 2 is there, okay, you multiplied with the multiplicative inverse. What is multiplicative inverse? It is a 1 by 2. Additive inverse means minus 2. What you will get? It is a 1. What is 1? 1 is a multiplicative identity. Multiplicative identity. Okay, this word you heard already: inverse, additive inverse and multiplicative inverse. Okay, inverse, additive inverse means you need to change the sign. Multiplicative inverse means you need to write the reciprocal. Okay, you need to write the reciprocals. Okay, similarly in the matrices also, what is the matrix inverse, the inverse of a matrix? Then if it is, suppose A is any matrix, then if you multiply it with the inverse of the matrix means you need to denote as A to the power of minus. It's a symbol of inverse of a matrix. Okay, A inverse, then you will get here identity matrix. You will get here identity. What is I? It is an identity matrix. It is the identity matrix. So if A is a matrix, if you multiply it with the A inverse, you will get the identity matrix. This is the only the simple thing. However, we solved in integers na, additive inverse, multiplicative inverse, same thing in the matrices also. If you multiplied with the multiplicative inverse of inverse of a matrix, then you will get the identity matrix. You know about the what is identity matrix also. Okay, now we will move to the definition here. Let A be a square matrix of order n. Okay, it should be a square matrix, remember that one. And if there exists a matrix B of order n by n such that A into B means A into A inverse, and it is multiplicative inverse is also multiplicative what is this one, commutative property, A into B into A equal to I, identity matrix, where I is the identity matrix of order n, same order. If it is 2 by 2, then B should be also 2 by 2 and I also same order. It's a 2 by 2 only. If you are taken order n, then B is also order n and I is also order n. Then the matrix B is called inverse of A and it is denoted by A inverse. It is the symbol of inverse. Okay, A inverse of B. The inverse of a square matrix is a unique. Unique means every inverse elements are unique only. It's not multiple. Unique means in a simple words you can call it as it's a single. Okay, unique means it's a single. See here, what is the inverse of additive inverse is what? What is 2 inverse? It is minus 2 only. It is minus 2 only. It is unique. Okay, if it is what is additive inverse of 100? It is a minus 100. Okay, it is unique only. The minus 99 is not a inverse of 100. Okay, it has only one inverse. It is only one inverse. It is a single. Otherwise you can call it as the inverses are unique. Like if it is you are taking the multiples of 2, you can take multiples of 2 means 2, 2, 4, 6, 8, 10. This is the like it's a multiples. It's not unique. But in an inverse, it is the case is you will get for one single integer you will get only one inverse. For what is the inverse of minus 55? It is a plus 55, only one. It's a unique. Okay, I am telling about additive inverse. Similarly, in the multiplicative also, if you take 1 by 100, what is the multiplicative inverse of 1 by 100? It's a 100. Multiplicative inverse of 1 by 100 is 100. It's only single. It's a unique. So you can call it as inverses are always unique only. So here also the inverse of square matrix is unique. Unique means in a simple words you can understand it is a single. It means it should be a only one matrix. Okay, A inverse, how to find out? It is a formula. How to find out means A inverse equals to adjoint of A and determinant of A divided by determinant of A. You know already how to find out adjoint of A and determinant of A. In the previous classes I explained in a detailed way, very in a simple way and detailed way. If you didn't check means please go and check that one. You will understand clearly here how to find out adjoint of A and determinant of A. Now see here, A inverse equals to what is the formula? Adjoint of A and determinant of A. And you know in the maths the denominator should not be equal to 0. You already know this one. If it is denominator equals to 0, any numbers, it's a no meaning. No, it's called it as it is a meaningless. Okay, so here determinant, what is denominator here? Denominator is here determinant of A. So determinant of A should not be equal to 0. Should not be equal to 0 means what? Determinant of A should not be equal to 0 means it should be a singular matrix. Then whatever your A now you are finding the inverse of that matrix, then that should be a singular matrix. Why? Because here A inverse formula is adjoint of A divided by determinant of A. Determinant of A should not be equal to 0. Otherwise it is A inverse is, if it is determinant of A equals to 0 if came. If any matrix, if they ask find the inverse of the matrix and you find out the determinant of A, it came 0, then you write down clearly A inverse does not exist because determinant of A is a 0. Denominator should not be equal to 0. Okay, hope all of you understand this two definition importance in the inverse of a matrix. So inverse of matrix is completely, it's a non-singular matrix. Determinant should not be equals to 0. This is the very important thing. You should remember this one. Okay. Here some properties, otherwise like note, you should remember these points here, it's very important. Okay, so I will tell this one. If a matrix A has a inverse, then A is called as a invertible or a non-singular. If A has a inverse, if it is, suppose I told you maybe have A maybe have inverse, A may not be have inverse, in which case if A is a singular matrix, it does not exist. Okay, A should not be a inverse. So if any matrix A has a inverse, then A is called as a invertible. A is, you can call it as, it's a invertible, you can make it inverse, you can find it inverse. Otherwise you can call it as non-singular, because any matrix having the invertible and like inverse means it should be a compulsory, it's a non-singular, so you can call it as non-singular, otherwise invertible. Otherwise A is, otherwise means if A inverse is does not exist, A inverse does not exist, does not exist, then that meaning is A is a singular, that meaning is A is a singular matrix. Okay, next, second point here, the inverse of a matrix is unique. I already told here the inverse of the matrix is only one, so it is a single. Okay, next, third point, the inverse of non-singular upper or lower triangular matrix is again upper and lower triangular matrix. We already see the what are the types of matrices. It is upper triangular matrix, lower triangular matrix. I explained in a detailed way. Upper triangular matrix means below the principal diagonal elements are 0, that is called upper triangular matrix. Lower triangular matrix means the above the principal diagonal elements are 0, that is called as a lower triangular matrix. If it is a matrix is upper triangular matrix means the inverse is also upper triangular matrix. If it is the matrix is lower triangular matrix, their inverse is also lower triangular matrix. Upper triangular matrix means, I will show you. Upper triangular matrix means, it is, suppose it's a principal diagonal 1 2 3, it's a below the principal diagonal elements are 0, below the principal diagonal elements are 0, then it is called as the upper triangular matrix. Upper triangular matrix. Then this A inverse is also comes same, the upper triangular matrix only. That meaning is the principal diagonal elements, below the principal diagonal elements will come 0. If it is lower triangular matrix, if it is a lower triangular matrix means, lower triangular matrix means the principal diagonal, above the principal diagonal elements are 0. Okay, you can take any number here. So if it is a lower triangular matrix, then A inverse is also comes lower triangular matrix only. That's it. If A and B are non-singular matrices, it's a non-singular matrices means that, what is the meaning of non-singular matrices? Determinant A is should not be equals to 0. Okay, then what are the properties will exist here? A inverse of inverse, A inverse of inverse is again A only. Okay, see here in the additive identity also, 2 additive inverse is minus 2, minus 2 additive inverse is again 2. Are you getting? Additive inverse of 2 is minus 2, minus 2 additive inverse is 2. So you can write it as 2 inverse of 2 is 2 only. Additive inverse of 2 is 2 only. Like similarly in the case A matrix A inverse of inverse is matrix A only, and AB multiplication is here, two matrices is there, A into B. A into B inverse is B inverse into A inverse. Okay, first it will come second matrix B, after that A. It should not be equals to A inverse into B inverse. It should always be B inverse into A inverse only, because commutative law does not holds good in a multiplication. A into B is not equals to B into A. Okay, next, third point, K is any scalar here. Scalar means it's a constant, like 2, 3, 4, any number. We saw scalar multiplication also. Scalar multiplication means that constant you need to multiply with each element of that matrix. Okay, K A whole inverse means you need to take K inverse and A inverse. It is multiplicative inverse, na? So you should write, it is K is a constant. It is, you need to write the multiplicative inverse. So it become 1 by K. Because it's a multiplication sign, it's not addition sign, it's a multiplication sign. So you know scalar you need to write the multiplicative inverse only. So it K inverse means it is a 1 by K. If it is suppose it is came 2 to the 2 inverse. 2 inverse means you write 1 by 2. Then you need to find out the A inverse. Okay, using the formula adjoint of A divided by determinant of A. Next 4 point. A transpose. Transpose means you know that one. The rows and columns are interchanges. Rows changes to column, column changes to rows. That is called transpose of A. A transpose of inverse equals to, otherwise you first find out the A inverse and do the transpose. Both will come same. Next 5th point. For a non-zero square matrix, by a matrix should not be equals to 0. Okay, non-zero square matrix means the matrix should not be equals to 0. It is a 0 matrix. All the elements equal to 0 means it's a 0 matrix. Non-zero matrix means A should not be 0 matrix. Then A inverse equals to, it is a formula how to find out the A inverse. It is a finding, first you need to find out adjoint of A and divided by determinant of A. A should be non-singular. Here the condition is A should be non-singular. Non-singular means determinant of A should not be equal to 0. If it is if in case determinant of A equals to 0 came, you should write that is A inverse does not exist because determinant of A equals to 0. Okay, this is the formula for, it's a very important questions. Find the inverse of a matrix. 4 marks definitely. It is a fixed question. They will ask for 4 marks every year. Okay, for PU second year and for BCA students also. It's a fixed question. Find the inverse of the matrix. But for 4 marks, they will ask not 2 by 2 matrix. They will ask 3 by 3 matrix. Okay, first we will, for understanding purpose, we will do first 2 by 2 matrix and afterwards we will do the 3 by 3 matrix. For 4 marks, they won't ask 2 by 2 matrix. They will definitely ask 3 by 3 matrix only. Okay. Now see here, find the inverse of a matrix A. Listen carefully. It's a once again I'm telling, it's a very important question. One question is compulsory for 4 marks. Okay. Find the inverse of a matrix A equals to 2 minus 1, 3 minus 2. Okay, it is a 2 by 2 matrix. First we need to find out determinant of A, because it tells us, determinant of A tells us whether A exists inverse, otherwise does not exist inverse. If determinant of A not equals to 0 means A inverse is exist. It is equal to 0 means A inverse is does not exist. So first we will find out determinant of A only. How to find out determinant of A? First you need to multiply principal diagonal. 2 into minus 2, it's a minus 4. In between minus sign will come. 3 into minus 1, it's a minus 3. Okay, minus 4, minus into minus is plus 3. So both are opposite signs, so it's a minus 1. Minus 1 is not equals to 0. So A inverse will exist. Now you find out the adjoint of A. Now you need to find out the adjoint of A. Adjoint of A is what? It is a cofactor of a matrix A transpose. First you need to find out the cofactor of a matrix A. After that you need to do the transpose. Transpose means rows interchanges to column. That is called as transpose. Then you will get the adjoint of A. So first I will find out the cofactor of 2, cofactor of minus 1, cofactor of 3, cofactor of 2. Okay. Cofactor of 2. How to find out cofactor of 2? It's very simple. It's diagonal elements only. Minus 1, it belongs to first row first column, so 1 plus 1, and it's the minor of 2 is, it's a minus 2. If it is power is even, minus 1 to the power of even, it's a plus sign only, so it's a minus 2. It is, you can call it as A11 also. Okay, next A12, cofactor of minus 1. It is minus 1 to first row second column. What is its minor? It's a diagonal element only. It's a 3. Minus 3 into minus into 3 is 3 minus 3. Next a to 1. Cofactor of a to 1 is 3. Minus 1, it is second row first column. 2 plus 1. If it is odd, 2 plus 1 is odd, then it will sign will come minus sign. What is 3 minor here? It's a minus 1. Minus of minus here, plus 1. Plus 1. Okay. Next a22. Cofactor of a22 is minus 2. Minus 1 to the power of 2 plus 2. What is minor of 2 minus 2 here? Plus 2. It is a plus sign, plus 2. So plus 2. Okay. Now we will write down the cofactor of A here. Adjoint of A equals to cofactor matrix transpose. I will transpose. It means to minus 3, 1 plus 2. Okay. What is transpose of first row changes to first column? First row is minus 8. Changes as a first column. 1, 2, 1, 2. So this is the adjoint of. Then A inverse equals to, what is the A inverse? Adjoint of A divided by determinant of A. What is adjoint of A here? Minus 2, 1, minus 3, 2. Divided by, what is the determinant of A? It's a minus 1. So it is a scalar multiplication. So you need to multiply this one. Minus 1 into, because minus 1 divided by 1 means it is minus. It will go reciprocal. It will come minus 1 only. Minus 2, 1, minus 3, 2. So sign will change here. So A inverse equals to here. Minus into minus, it's a plus 2. Your scalar multiplication means you need to multiply minus 1 with each element of matrix. Minus 1 into 1 is minus 1. Minus 1 into 3 is plus 3. Minus 1 into 2 is, it's a minus 2. So this is our A inverse. Hope all of you understood this one. Okay. Now we will do another one question, 3 by 3 matrix. We will find the inverse of 3 by 3 matrix here. Solution. What is the formula? A inverse equals to adjoint of A divided by determinant of A. First you need to find the determinant of A. Okay. First I will find out the determinant of A. How to find out? You need to take here plus minus plus sign. You need to find the determinant of the submatrix here. Minus into minus plus 30. Minus 0. If it is suppose it's in the first row only 0 came, not need to do this bracket. Okay, because 0 into I think 0 only. I am right here. You can skip in exam for time management. Because 0 into this bracket, anyhow whatever the element will come, 0 into anything is 0 only. So 6 3 is 18. 0 into 4 is 0. So 1 is plus 2. It is 0 only. Minus 1 minus 18. So 2 plus minus into minus is plus 18. So it's 20. Determinant of A came 20. Next, for finding the adjoint of A, first we need to find out the cofactor matrix. So after the finding cofactor of matrix, you need to do the transpose, that is equals to adjoint of A. So I will find the cofactors of these elements. Okay. First I will find out the cofactors. A11. It is a cofactor of 1. minus 1 to the power of 1 plus 1. How to find out this one? You need to close first row and first column. Elements. 4 sevens are minus 28 plus 30. Okay. It's a even number. Minus 1 to the power of even. It's a plus sign. Minus 1 to the power of odd. It's a minus sign. Otherwise, this sign portion you can write alternative sign, plus sign, minus sign, plus sign, minus sign. It will come alternative only. Plus minus 28 plus 30, it's a 2. So answer is plus 2. A12. So cofactor of which one? 0. It is minus 1 to the power of 1 plus 2. Minus 21 minus 0. So minus of minus 21. It's a plus 21. Plus 2. Next A13. Cofactor of minus 1. It is minus 1 to the power of 1 plus 3. How to find it? You need to close the third column and first row. 6 3s are 18 minus 18 minus 0. So it will come plus sign because 1 plus 3 minus 18. So it's a minus 18. Next, second row. A21. Cofactor of 3. It is minus 1 to the power of 2 plus 1. 2 plus 1 is odd. So you need to close here first column and second row. 0 into anything is 0. Plus 6 and it's a minus 6. Minus of minus 6. It's a plus 6. A22. Cofactor of A2 is a 4. Minus 1 to the power of 2 plus 2. Okay. Second row, second column you need close here. 7 to minus is minus 7. So plus 0. It's plus sign and minus 7. So it's a minus 7. A23. Cofactor of 5. So you need to close second row, third column. Minus 6 into 1 is the minus 6. 0. It's a minus of minus 6. So it's a plus 6. Next, third row. A31. Cofactor of 0. Cofactor of 0. It is a minus 1, 3 plus 1. 0 means you need to close here first column and third row. 5 into 0. It's plus sign only. 4. Next, A32. Cofactor of A3, it's minus 2. You need to close the third row, second column. 5 is a 5. Minus sign plus 8. It's a minus 8. Last element, that is A minus 7. It's a minus 1 to the power of 3 plus 3. It's plus 0, minus 0. Plus. Okay, now I will write here cofactor matrix A. What is first row? 2, 21 minus 18. Second row is here 6 minus 7, 6. Third row is here 4 minus 8, 4. This is the cofactor of A. And in the previous classes, I explained in a detailed way how to find out the cofactor of A, what is the meaning of minor of A, how to find out adjoint of A. Still you didn't check means please go and check that one. So adjoint of A equals to cofactor of A matrix transpose. So adjoint of A equals to, we already got here the cofactor of a matrix A here. So it's the same thing I wrote here, that transpose. Okay. So adjoint of A equals to here transpose of this one. How to do transpose? The first row changes to first column. 221 minus 18, 6 minus 7, 6, and 4 minus 8, 4. Okay. What is the A inverse equals to? A inverse equals to formula 1 divided by determinant of A, adjoint of A. Okay. What is one determinant of A? Determinant of A we got here 20. Adjoint of A here 2, 6, 4, 21 minus 7 minus 8, minus 18, 6 and 4. So this is the A inverse. Okay. If it is in the matrix now, it is a multiples of 20 means you can do the scalar multiplication. Here it is a 2, 6, it's less than 20 only, it's not possible. So better you keep like this only. Okay, not need to do anything. So A inverse equals to 1 divided by 20 into adjoint of A. Okay. Hope all of you got this one. It's a very important, very important questions for your board exam. 4 marks question, 1 compulsory. Okay. If you are like the videos, if you are getting understand means please like the videos and share to your students also. Please subscribe the channel. Thank you.